For this rational function, we are going to be determining the asymptotes, and then we are going to look at the graph of the function. So first of all, if we factor the denominator, first of all, we do see that we have vertical asymptotes at x equals 2 and at x equals negative 2. So we're going to go ahead and indicate that. Vertical asymptotes. X equals negative 2, x equals 2. Because those are values that cause you to divide by 0, but the top is non-zero. And again, remember to always write it as x equals negative 2 and x equal to 2. Don't just say negative 2 and 2, because you're actually giving the equation of those vertical lines. Now the horizontal asymptotes, it doesn't have any because the degree of the top is greater than the degree of the bottom. However, it may have another type of asymptote called a slant asymptote. Before I go on to that, a thing that can actually help you to graph is to look at the function itself, where the function itself is going to be positive or negative. So I'm just going to indicate function itself where it's going to be positive and negative. Because first of all, the function does go through the origin. If we substitute for x, we're going to get x over negative 4. 0 over negative 4 would give you 0. And then it has its asymptotes at negative 2 and 2. So I'm going to indicate that the function is undefined at these 2 points, where you have the asymptotes, undefined and undefined. But then again, to help us graph it, we can look and see where the graph is positive and negative. For values greater than 2, we're going to have positive, positive, positive. The graph of the function is going to be positive for all values of x greater than 2. Between 0 and 2, such as 1, we're going to get positive, negative, positive. Values of x between 0 and 2 are going to create a negative part of the function. Between negative 2 and 0, for instance, negative 1, negative times positive would give you positive on that interval. And for all values which are less than negative 2, we're going to have negative divided by negative times negative. So everything is negative there, negative. That's going to help you to graph the actual function in terms of what portions of the graph are positive, negative. Now it has another type of asymptote called a slant asymptote, or also called an oblique asymptote. And the indicator that we're going to have a slant asymptote is when the degree of the top is greater than the degree of the bottom. And the way we find that is to do long division. X squared minus 4, divide that into x to the third. X squared times x to the third would give you x. Multiply by x and subtract. Gives us a remainder of 4x. And we can't do any further division. So therefore, the slant asymptote is y equals x. All right, let's take a look at this graph, knowing that it has asymptotes of x equals negative 2 and x equal to 2, and a slant asymptote of y equals x. And then the graph of the function is going to be positive on the intervals negative 2 to 0 and 2 to positive infinity, and negative, meaning below the x-axis, on the interval from 0 to 2 and everything less than negative 2. So to summarize, our vertical asymptotes are x equals negative 2, x equal to 2. It has no horizontal asymptotes, but it does have a slant asymptote of y equals x. And again, remember to write down x equals negative 2, x equals 2. And for the slant asymptote, y equals x. You're giving the equations of lines. And therefore, The entire graph of the function looks like this. Note the two vertical asymptotes, the slanted asymptote y equals x, and then where the graph is positive and negative, and the graph actually goes through the origin at the point 0, 0.